Okay, so this is chapter 3, section 2, gravity and motion, orbital motion and gravity. And we should have just watched that movie about Newton. And I wanted to watch that because I think this will make more sense. The lecture here will make more sense. So Newton was not the first person to attempt to discover and define the forces that hold planets in orbit around the sun. Nearly 100 years before Newton, Kepler. And remember, Kepler is the guy that worked with Tycho, who made all those beautiful gauges and machines. Kepler recognized that some force must hold the planets in their orbits and proposed something similar to magnetism might be responsible. So he knew there was something out there that was holding everything together. He thought maybe it was some sort of magnetism. Okay. Then Newton wasn't even the first person to come up with the word gravity. And think about gravity. That was Robert Hooke. And remember in the movie, you saw where Hooke's laboratory burnt down, so he couldn't really prove any of this stuff. But anyway, Newton was not even the first person to suggest that gravity was responsible. That honor belongs to Robert Hooke, another Englishman who noted gravity's role in celestial motion several years before Newton published his laws of gravity in 1687. But that doesn't necessarily mean he came up with the idea first either, because we know Newton would come up with these ideas and never say anything to anyone, okay? Moreover, Newton went on to derive equations that describe not only gravity, but also its effects on motion. So Newton made the math. He crunched the numbers and he made the math up. Then it goes on here to tell us about the story of the apple, which we're not sure if it's really true or not. Might just be a story that he did. But most of Newton's work is highly mathematical. But as part of his discussion of orbital motion, he described a thought experiment to demonstrate how an object can move in orbit. And that brings in this great canon thought experiment about how he figured out orbital motion. Now, believe it or not, we use this today to put satellites in orbit, the GPS satellites, to get the space station out there, to send supplies and that to the International Space Station. All of this is done with Newton's first law. And that's what's so amazing about his first law. We can explain all of this whole thought experiment, without using any math, okay? And that's what's awesome. Notice that in the above discussion, we used no formula, no math. He could tell you how this worked without using math. And we saw that, so I'm not going to go over. We saw this thought experiment in a movie yesterday. So if we apply the same reasoning to the moon's motion, we conclude that if that moon works like this cannonball, the moon moves along its orbit because its inertia carries it forward, and its path is curved, not a straight line, because the force of gravity is deflecting it. Okay, and again, this is all done without math. But what I really wanted you to see in that video, other than the background of Newton, was this thought experiment. It's huge, and it completely changes everything. Now, as we move along, the math involved in this is his second law, F equals ma. What kind of acceleration do I need on this mass to make it fall into orbit? And then the other one coming up too is his third law. For every force, there's an equal and opposite force. For every action, there's an equal and opposite reaction. If the moon and the earth didn't have the exact same force on each other, the moon would either fly away or it would come crashing into the earth. The force between the earth and the sun are perfectly balanced. If not, we would be pulled into the sun, or we would fly away from the sun, okay? So for every force, there's an equal and opposite force. F equals ma. Force equals the mass. The force of gravity equals the mass times its acceleration. All right. I hope this helps you with this section. Good luck.